too broad of a brush, but so I'll apologize for my presentation skills and on my presentation content, I hope. I want to talk to you guys about our journey to deployment of Kubernetes resources at scale. I'm part of the DevOps squad. For those of you playing bingo, that's one of your squares. I'm part of the DevOps squad for IBM Kubernetes Service. There are basically 5 of us. If you go look at our open source repos, just about everything there is from one of us. There's one guy we used to have on the team who went to another project, so you may see some commits from him, but it would likely be one of us. So our project is called RAZY, which we chronically mispronounce Razzie, because it's more fun to say. If you're going to work in IBM Kubernetes land, at least, and I think this is probably true in many places, mastering your nautical terms is essential. So when we first joined the Kubernetes service a couple of years ago, we naturally went to Wikipedia to study up, and we chose RAZY as our term and represented what we're trying to do.
Important question. Does that mean you have to learn pirate terms?
You just have to be able to adopt a pirate accent.
Okay.
Yeah, that was terrible. Anyway, a RAZY in the age of wooden warships would be a ship of the line who had been surpassed by the next larger generation. They couldn't fight head to head with a competitor ship, didn't have firepower, didn't have the armament, didn't have the staying power, and so they would cut the upper decks away to make it a faster and more nimble ship. And that's what we set out to do, is to make our tribe faster and more nimble by loosening some of the constraints in some of the process. So it's kind of 5 areas that we tackled in that. First is visibility into what was where. When you're managing one cluster, what's where is pretty easy to find out. You look at the kube dashboard and you know exactly what's there. When you get up into the hundreds, thousands, tens of thousands, that gets to be harder to know. Culture. Most of us, at least some of us, have earned our gray hair and have delivered products in the past. I go far enough back to have delivered 3.5-inch floppies as a product deliverable. Most of you guys are probably DVD or CD-ROM delivery. There's a mindset shift that's necessary to go from I'm going to burn these things and hand them to you, or I'm going to host a service and I can be updating, tinkering, improving, enhancing that service every day, every hour of every day. So it was a transition for our tribe to go from we're going to deliver monolithic things together infrequently to we're going to deliver very discrete things very frequently. We had to scale. We started with a few clusters in a single data center. IBM Kubernetes Service today is in, the stats are in here, several dozen data centers across 6 regions all over the world. Managing our configuration and keeping that configuration secure. When we first kind of started with just a handful of clusters, we had a private Git repo for each cluster that had all of its secrets and all of its configuration. And if you were in the know, you could see everything. And if you were out of the know, you could see absolutely nothing. And that worked great for the in the know people and terrible for the out of the know people. And it ultimately caused problems. It's easy for one more person. When we finally started trying to make this transition, there were 85 people that had access to the keys to the kingdom, which is probably a few too many. The last is we have begun transitioning the work we've been doing over the last couple of years into open source. All the code, all the capabilities that I'll talk about and then I'll show you. We have been working on making it available. Like any good team, we set out solving our problem and we added to, and we added to, and we added to, and we got to where we felt pretty good about what we were doing. And our peer services within IBM and our customers said, "Hey, how do you do what you do? You guys are pretty big. What do you do?" And we would show them, and we would talk to them, and they're like, "Great, how do I use that too?" And we're like, "Well, this part's a little specific to us, and this other part is a little specific to us. We'll get back to you." And the way we've decided to get back to them is to decompose all the pieces that we've built and then publish it in discrete components through GitHub.com. that other projects and other companies can use this. We've written it to work with any Kubernetes service, not just IBM's Kubernetes service, as long as you have a working kube. And assuming we have a successful demo, I'm actually going to demo on Minikube just running on my laptop here. All right, so RASI is comprised of three sections. The continuous delivery or operator pieces is a set of custom resources and controllers that we use to affect deployment onto our various clusters. Watchkeeper is how we gather data about what's running on that cluster. And RASI Dash is how we visualize that data. So this is the technology that we use. We're not very tightly coupled to any of these pieces. All of our source is in GitHub repos. For our internal development, IBM uses GitHub Enterprise, one of the larger, if not largest. Yes, Rafa.
So you tied it to GitHub, but is it tied also to Travis?
So we use GitHub and we use Travis, but it is not tied to either. So momentarily, I'll talk a little bit about how one of the things that helped us was to recognize that our continuous integration could be and should be separate from our continuous deployment. Anyway, so this is the technology we use. So a consequence of our continuous integration is the publishing of a set of YAML configuration for Kubernetes out to IBM Cloud Object Storage. IBM Cloud Object Storage, for most of you who probably don't know, is an object storage service that implements the S3 protocol. That could be Amazon Object Storage or any number of other object storages. The S3 protocol is so dominant that if you're going to be in the object storage business, you have to speak S3, and that's what that is. And then on the, so our CI process pushes artifacts into that storage repository, and then our clusters actually pull the data from that. And that's one of the other things that we've done. I'll talk about that momentarily. So what is IBM Kubernetes Service? It is a host of Kubernetes. You can run any number of Kubernetes versions as well as managed OpenShift. It's part of the overall IBM cloud. We call our internally our project Armada. I'm thinking whoever named that was not familiar with what happened to the Spanish Armada, but so far we're sailing good. We work off of private image repositories internally, so when we build Docker images, we push those up to the various IBM registries and insert them up from there. Those registries integrate into vulnerability analysis that are constantly scanning for known vulnerabilities off of your Docker images, and we service that internally to ourselves. And of course, we have an internal implementation of this that we are, like I mentioned, in the process of decomposing and sharing the code out. Some of the things that are in there, we probably will never share, not because they're secret, but because they're just are part of, they're integrated into our business processes. So for instance, for our audit history, we keep tickets in ServiceNow. Not everybody's using ServiceNow. It probably doesn't make sense for that to be that tightly coupled. It's tightly coupled as it is in our internal implementation. So you won't see that in the external unless there's just an overwhelming interest. All right, so I talked a little bit about the span. Interestingly, we define our 6 regions as AP North and AP South, EU Central and UK South, which I think was actually named before the Brexit vote. So somebody somewhere has a future in political prognostication as well as technology. And then oddly, US East and US South. I'm not sure what happened in North and West, but we might get there someday. The basic architecture of the IBM Kubernetes Service is each region has a collection of hubs and spokes that they delegate work to, and those hubs and spokes are responsible for managing what we call either cruisers or patrols. Every geometric shape on the screen is a Kubernetes cluster. So we're running Kubernetes with Kubernetes. Our hubs are crew clusters, and we deploy Kubernetes workloads to those to do that work along with all the spokes. Cruisers are what we call the clusters that we examples are the clusters that we manage that are free, which is a never-ending battleground of Bitcoin miners, but they get their own special name. So in terms of scale, we've gone from relatively few to relatively many. The control plane clusters, those hubs folks, there's a little over 100 of those right now in our environment. There's tens of thousands of customer clusters in our environment. Within the control plane, we're managing roughly 1,500 workloads and hundreds of thousands of deployments across the customer clusters. And of course, our teams are quite dispersed across the globe as well, as you would expect from IBM. So first step in our progression from where we were to where we are is we had a problem. This actually was easier than you would have guessed. A couple of our very best engineers spent a good chunk of their time just dealing with deployments. So each deployment for each microservice would take 3+ hours to accomplish. They were only able to deploy once or twice a week, and so more and more commits are stacking up over that time before the elephant passes through the python. And when something goes wrong, it could have been any of those commits. And so now you've tied up some of your best engineers who are sort of managing the deployments, as well as the people who have stuff that went along on that ride to try to figure out what's wrong. Like I said, this was actually relatively easy. I mean, the guys who were spending a third of their time trying to debug other people's problems were like, yes. And the people who are the various squads delivering the various microservices, they were ready to be able to deliver faster. So this was the easiest thing. The second, we talked about this a little bit before, fixing the culture. So lots of squads and lots of people sort of still have that product delivery mentality. We kind of had to step back, think about delivering a service and how can we deliver in smaller incremental pieces. If you're delivering 30 commits twice a week, something goes wrong, it could be any of 30 commits. If you deliver one commit every hour or every day, something goes wrong, pretty easy to figure out which commit it was that messed it up. So some of the principles that we try to follow: visibility and transparency. One problem that we initially identified was we were working off of a push model where we had Jenkins jobs that would reach out to every cluster. You get version 2, you get version 2, you get version 2. And then when it was all done, everybody said, great, everybody's running version 2. Except for the guy in the middle who had an error and he's still running version 1, but nobody knew that. So we wanted to be able to have visibility into what was going on there. We also wanted transparency across the squad so that people could see what's going on, what's changing, when it's changing. Second was to decentralize and decouple, to give our squads some autonomy and some trust. So it inevitably comes up, how do I prevent Adam from putting something out that doesn't work? You give Adam the tools to test it well, to detect that he's put something out that's bad, and to fix it quickly. So if it's going to take a whole week for me to put a fix out for something that I messed up, I'm super trepidatious about putting anything out. If I can put one discrete thing out and I can easily turn it on and off and I can back it off, I'm less nervous. I'm not less careful, but I'm less nervous and I have a faster turnaround time. All part of minimizing the friction. Friction is death. We have to standardize. There's always a few snowflakes. So my thing is special. We're all special, but if we can all apply the same tools and sort of follow the same techniques, we can all get to the same place. And of course, simplicity. That's kind of a buzzword. What's running? So getting visibility. When we kind of first started on this journey, there was, as you might guess, there were some skeptics, as there are always skeptics. We know what's running. We know version 2 is running everywhere. And when we pulled up the dashboard where we pulled live data from all the clusters, and like, okay, there's about 5 different versions of this thing running in the various data centers all over the world. It helped a lot. So this is just some screencaps of what our internal dashboard looks like. There's a couple different views. We have a view by clusters, where you can go find a particular cluster that you're interested in, see what's running on it, see what versions it's at. You can hone in by resource. So you can pull up a particular microservice, see all the clusters that it's running on, all the versions that, that may be running in various data centers, and you can actually see the change history. And we have links from this back into GitHub, so you not only know this Docker image changed from X to Y 6 days ago, you can actually see precisely what changed. Build and deploy. The way we're set up today for our microservices is every time a squad commits to the master branch in GitHub, the Travis build runs, it publishes the configuration artifacts, it publishes the Docker images if there are, if it's a most of our pretty much all our microservices have Docker images they publish. And it publishes a version variant to a feature flag service that we use called Launch Darkly. It's a little bit of a leap for us and for others that we've talked to think about using a feature flag service to manage versions, but that's actually what we do. So a classic feature flag service would say I've got some new capability, some new widget in my UI, and it's a binary. You're on or you're off. And if you're on the left side of the room, you get the blue button. If you're on the right side of the room, you get the red button. And we're going to see, if we're doing an A/B test, we're going to see who's more likely to click the try me button. We're using this in a multivariant mode, where each feature flag can have many variants, and we can write rules against those variants. So the way we manage this, again, following a pull model, all of our clusters are constantly checking what should I be running, and then trying to enforce that on that cluster. So we'll write a rule that says all the clusters in AP South should be running today's version. And every one of those, generally within 60 to 90 seconds, will detect that version change, pull that down. It's been a great relief of work from our microservice development squads. Each time our environment grows, each time we add new capabilities, each time we add new data centers, the work on them doesn't grow. The work on the SRE guys grows in the sense they've got to stand the data centers up, they've got to deal with the underlying virtual machines that the stuff's running on. But on the development squads, you're just setting rules. So automatically, at the end of every master branch build, we push our artifacts and we set a rule that says this version should be running in the dev region. We actually maintain a region for developers so that your latest and greatest code is always there. So as soon as that Travis build finishes, minute and a half later, your new code's running in dev. I mentioned this before. CI not equal CD. I've done this, and I see a lot of cases where people do this. And if you've got in my experience with a relatively small number of environments, it's not a terrible way to go. You got, in Travis or Jenkins, at the end of your build process, you can say, I want to push this over here, I want to push it over there. To have Travis sit there and push to tens of thousands of clusters, not going to happen. So decoupling those two. So our CI process produces what we essentially consider immutable artifacts. They're technically mutable. There's YAML files in object storage. There's Docker images. But essentially, by process and by policy, we don't change those. Once that master build finishes, yes or off.
Sorry, but so let's assume that you push the commit and it gets built, and then I push a commit and then it gets built. So my commit has got your commit. What if I don't want your commit in my push to my pull cluster?
If my commit's part of master, you're stuck with me. You can revert me. Let's say I screwed it up. You can revert me if there's something wrong with my commit. But once it's part of the commit history, if it's staying in the master branch, it's staying. We do have a process in place. If you've got something, I just have to try this. I don't want to integrate it with everything else. I need a quick try of this in the dev environment. We have a way to get it there. But we beat people thoroughly with wet noodle if they try to go any further than the dev environment with those things. Push versus pull. We don't deal with clusters. All the clusters deal with us. So all the clusters phone home, phone home, to find out what they should be running, and then they go to the repository to pull the necessary configuration artifacts. We deliver configuration as code, just like any other code. And we do this just to have our squad strive for rapid incremental updates. Again, if you've got 1 or 2 commits that you're going into dev or pre-prod with or production with, and something's not right, still have to debug the problem, but I don't have to figure out if it was me or him. We know which one of us it was pretty quickly.
You started to mention earlier, but could you go a little bit more why Pull is working pretty better than Twitch?
Pull is working better for us because of the scale. So if we obviously, there's occasionally times where you need to reach out and touch. I use in the Jenkins jobs, it takes over 3 days to touch every cluster. Whereas with a pull model with the rules, every cluster phoning home working independently, it takes a matter of 1 to 2 minutes to update them all. We don't typically update every cluster worldwide simultaneously. We could, but we just assume if there's something wrong, not take every region out simultaneously.
Phoning home, so it's talking to a server, and the server is not capable of taking loads.
So, you know, one of the most scalable services I've ever used, at least from IBM, is object storage. It's scaled, it's clustered. Knock wood, I've never experienced any downtime with it.
So it's putting everything in storage.
Yeah, it's pulling it straight from object storage.
There's no in service in the middle.
Nope.
So that service is shared. Service is shared with all the clusters. Sorry, I mean the object storage is shared with all the clusters.
The object storage is hosted worldwide. We kind of follow different models. In some cases, we're actually transitioning to where every microservice will deliver its artifacts to its own separate bucket. We started with everybody together, and as we've grown more and more microservices, we've realized how difficult that's been to manage, or going to be to manage. So we're in the process of divvying the microservices up into each their own separate bucket. But the object storage service provides that worldwide scale, that content delivery for us. We've more or less seen this picture already. I talked a little bit about LaunchDarkly. It is a feature flag service that we use. It's not necessarily something that you have to use. And part of our open source artifacts, we've built support for that. But it's a separate, discrete artifact. So with LaunchDarkly, they talk about advertised versions. So whenever I, as a cluster, check with LaunchDarkly, what versions should I be running, I provide identity. Part of my identity is descriptions of myself. So not only do I give LaunchDarkly my cluster unique ID, every cluster has a UUID, I also give it the region that I'm running in, data center I'm running in, some other stuff. So we can write rules. Typically, we just write rules off of data center so that we will deploy whole data centers at a time. There are a few squads that are a little more cautious and want to risk taking a whole data center out, so they will deploy to a single cluster, make sure one cluster in that data center is good before they do the rest. Other squads, the way their stuff works and scales, they can hit a whole data center simultaneously. And I know at least one guy who will actually do all hundreds of thousands of nodes simultaneous, and those all update within a minute and a half. So this is an example of what LaunchDarkly rule setting looks like. So you can see here, this is the feature flags we have for managing deployment. I don't actually know which feature we're looking at, but it doesn't really matter. So you select a particular feature flag, and a list of the variants that are available for that microservice. So our features are our microservices, and our users in this model are our clusters. So each cluster is a different LaunchDarkly user. So here we've got rules for the RASI clusters. We have a few clusters that we run our services on, and then of course we've got the control plane clusters, and they're grouped in regions like we talked about: UK North, UK South, EU Central, UK South, etc. So you pull this up, you hit the drop down, gives you a list of the available variants that you could advertise for that group of clusters. When you set it, save it. I think LaunchDarkly guarantees, or at least suggests, they deliver that event within, I can't remember how many seconds. I think it's actually sub-second, but don't quote me on that. But it's quick. So all of the clusters get that new advertised version within a few seconds. Then it takes us approximately a minute to go to object storage, download the artifacts, apply them to the Kube API, and affect the change. The operators that we've written are constantly enforcing, so they're regularly going back to object storage, doing a request. Have changed since last updated since the last time I pulled it. We don't ever mutate the artifacts in object storage because it doesn't mean other people don't want to. So we have implemented things so that if the same file has changed, it'll pull it and apply it. I talked a little bit about dealing with secrets. This was miserable if you were on the outside, because not only could you not see the secrets, which you don't really need, but you couldn't see any of the configuration values. How do I know which config map I should look into to find the registry I should talk to? How do I know, where do I get the URL for talking to the logging service? The whole thing was obscure. It was either all open or all obscure. We've rebuilt that. This is part of, we really treat our configuration like a microservice. We deliver it using the same techniques. When it builds, it uploads to an object store, and the whole model pulls that configuration down. That's the first thing it does in the cycle. So this is kind of how we restructured that. So we put all of our configuration artifacts, which is turning into a fair number, into the same repo, and we organize them around a hierarchy. One of the other problems with having a separate private repo for each cluster is you need more and more and more and more of them as you grow out your backplane. And almost all of them have some of the same data in them. So we've organized all of our configuration hierarchically. So there's some stuff that is just global in scale. Every cluster all over the world gets the same configuration. That's the little top triangle there. And we've got stuff that's regional. So which etcd service should I talk to, for instance? Those are typically regional. The URLs to talk to, as well as the API keys that you need. Where we differentiate, then next level down, we have configuration by the type of cluster. So talked about at least 4 types of clusters. We actually operate a few more types that didn't make the chart. Different cluster types get different configuration, and they get different microservices running on them. So hubs run more things than spokes. Spokes run more things than cruisers. Browsy clusters run just our stuff. This allowed us to eliminate a lot of duplicate configuration. And it allowed us to make this visible. One of the things that we did is we actually went to the secrets that are in the repo are encrypted, and no one but the CI tool has the decryption key. It's not quite true that the common tool have it, but basically no one has the decryption key. So everybody on the squad can see everything, and when they want to see the secret, they see an encrypted string. We actually have all the way at the bottom, we don't use this very much, the ability to have unique configuration on an individual cluster basis. That doesn't come into play very often, but it is technically possible. Feature flags. So not only are we using feature flags for controlling our version, but we are beginning the adoption process of using feature flags for our content. One of the problems, if I say, well, every time you have commit a couple of things, you want to go ahead and roll it out into production. Well, the thing I'm writing is going to take me a whole month, some new capability. I don't want that code all stacking up on my system, but I also can't have every user getting a brand new button that doesn't do anything. So we're in the process of adopting feature flags for feature control. So initially, the feature flag just hides the whole feature. As it begins to take form, we turn it on for our offering managers and whatnot, so they can begin to get a feel for how this works. Even if it's not super stable, it's stable enough for them to try. And then eventually, when it's ready to launch, we haven't quite gotten here yet, but we're hoping to get to the point where when the offering manager is ready to go to KubeCon and say, look at this brand new thing, he can turn the flag on 5 minutes before he goes on stage, and suddenly everybody gets it. We're not there yet, but that's what we're trying to get to. But by using the feature flagging, it lets you go ahead and move stuff out of your branch and into production. So you find out earlier if you're disrupting other parts of the system, and you can begin to expose that feature progressively to more and more people. First your squad, then the architects and whatnot, then the offering management team, and some of your favorite customers who are understanding of what under development really means, and then of course eventually to all of them. So this sounds like the old joke of we don't need to test, we let our customers do that, but it's a little bit different in the sense We are testing in production, but the customers aren't actually the ones testing it. It's the developers that have access to turn the flag on for their use. And we're still building the skill, honestly, of how to actually enable a feature that spans multiple microservices, because they all have to be sensitive to the same flag who can use that capability. We're progressing, but in all honesty, we are still learning. All right, any questions before I start flipping my glasses up and down on my board? All right, so I'm sharing with you the Resi IO. No, okay. I hope to stand and talk more than kneel and squint. So all of the code that we've refactored to make available to you and anyone else to use, contribute to.
Can you zoom in a bit?
Can I zoom in? Probably.
Ooh, thank you.
Okay, so we kind of have an overview. We actually are hosting the dashboard end of this for just trial purposes. I discovered this afternoon when I was getting ready for this, it has a couple bugs we still have to work on, but that's software. We're in the process internally of migrating all of the stuff that we built. I've talked to you guys a little bit about the monolith that we built to solve this problem for ourselves. We're in the process of migrating over to these open source components bit by bit. I've got all but one deliverable now converted to the new open source code on one of our cluster types. We've solved some good problems as we've gone through that. Okay, so this is a little demo that we put together. I'm actually going to, so the pieces of the open source Resi componentry, there's three groups. There's the Resi Dash and Resi Dash API. API is for ingest of data. The dashboard is for visualization. There's the Watchkeeper that watches all the resources. One of the things that we did when we built our version is we were primarily interested in watching workloads. And so our data gathering internally basically just gathers workloads. We realized as more and more people develop custom resources, deploy operators, put other artifacts in their kube clusters, they would want to be able to report on those. So Watchkeeper actually works off of a labeling model where you label whatever you want watched, and it'll collect data about that and send it up. We're still working on the visualization of that. I'll show it to you. It's, if you collect a lot of data, which I did for coming here, it's a lot on screen. We've got to work out how to filter that down and collapse that down a little bit, make it a little more useful. And the last part is the operators. So there's a few operators that I'll show you and talk to you about. Actually, let me just go. So there's the Watchkeeper. So the principal pieces are we have a LaunchDark with feature flag set that lets you bring in the evaluation of LaunchDarkly rules. So it creates what looks internally like a config map. So it itself is a custom resource with a controller that does the connection, pulls the data from LaunchDarkly and makes it available. Using a mustache template to allow you to use that data or several other kinds of data for modifying kube resources in memory. And we principally use that, at least in this demo, we use that to control what version of stuff that we run. And then we've got a group of remote resources, plain old remote resource that just pulls an arbitrary URL, remote resource S3 that knows how to take S3 auth credentials and authenticate to an S3 provider and pull it. At least if you use the HMAC path, it works with AWS and with IBM. I haven't tried it. I don't think I've tried it with any others. No, I did try it with many. Worse than many, I think. And then we've actually got one that for some of our customers, we told them how we do some of the things some of the configuration that we do. So I talked to you guys about how we put all of our configuration together. We actually encrypt that configuration for particular clusters. So we've got a remote resource that knows how to decrypt. So know that you can provide it with a reference to your private key, and it can decrypt the artifact, the resources after they come down before it applies them. In all these cases, each of these operators is a custom resource with a controller, which is an operator by the Kube definition of operator anyway. So it takes those resources, it unravels them, does whatever substitutions you want in the templating case, and then applies the resources and keeps up with them as children. Okay. So one of our demos, this demo we put together in conjunction with one of our customers, just kind of shows how you would how you can use the pieces together, and it can be a little subtle thinking about the features. So the first thing we have, of course, is Bootstrap. So here we say we're going to have this list of resources that we're going to bootstrap onto a cluster. The first thing here is the cluster info metadata. This is a description. So in this case, my cluster name is 007, and I'm a dev cluster. I've got some secrets, and if you decode these, they will not be very interesting secrets. Obviously, we have plenty real secrets here. This is where you would put your, if you're working with Cloud Object Storage or another S3 service, you put your keys as well as your API key for launch directly. Here we have the feature flag set, which basically just says what cluster info provides my identity for launch darkly. So operate off of the information in there in interpreting the rules and expose this as the default feature flag set LD. This gets a little more interesting. So if you ever use Mustache, this is a Mustache template processor. The templates themselves turn into resources after they've been run through the processor. So here we've got, within the template, a remote resource S3, and if we come down here to the URL, so I'm actually pulling this straight from GitHub Raw, which I don't recommend, but it does okay for demo, usually. Here I'm going to pull the config feature flag variant from Launch Darkly. If you go look at Launch Darkly, I look at config, I've only got one rule, and it says my default is config version 1. For the demo, I've only got one version of config. If we go into, say, Redis master, I've got two versions of Redis master, 1.0 and 1.1. So once we've bootstrapped, so one of the things you'll notice is the bootstrap actually points at the configuration. So now, anytime I update this configuration, that new version of configuration can be set in Launch Darkly, and that version will be delivered down. So here in the configuration, we're reinforcing all the things that we put on the bootstrap. So if we ever need to change them, supplement them, they'll be pulled automatically onto the cluster. And then, of course, the last thing is I've got my bill of materials and the things I want delivered onto this cluster. So in this case, I'm going to deliver front end. This is the front end Kube sample application that all of you Kube people know and love. And if not, it's a pretty boring application, but it kind of gets the point across. And of course, Redis master. And lastly, I of course got each of my microservices represented here. So in the front end case, I've got 3 versions, and we'll just look at version 1. Version 1 is a Kube deployment. It's the workload, and this is all the configuration. If you go just pull front end from the Kube samples, this is exactly that code. It's just we've just wrapped it in a version. All right, so let's see if I can break this publicly.
Could you make that a little larger?
Possibly. Better? Okay.
So your end users aren't really ever gonna, if everything goes well, they won't see anything. They're running whatever cluster solution they're doing, and they're just way down somewhere. They may or may not know that they're in the east or the south.
Typically they know because they provision the cluster, and they typically choose what region they want their new cluster provisioned in. And typically people will generate clusters in multiple there's multi-availability zones within the same region, so we have data center fault tolerance. We typically, for some of the services that we operate, will actually create clusters in multiple regions, and then we'll use a load balancer on top of that. So if for whatever reason Dallas gets flooded, we still have Washington, or vice versa. Okay, so I'm going to bootstrap this cluster. Just want you guys to see the shell script that I'm running here. So I'm creating a namespace. I'm going to put some secrets on. I won't share those with you. And we're going to bootstrap RASI, and then we're going to actually put on each of the operators.
Does RASI though also deploy these customer nodes? No.
Well, that's it partly. So the bulk of the work that we do with RASI is managing the microservices in the control plane. There's a lot more services there. There are some services that run in the customer clusters that we actually also manage with RASI. We probably do it more for enforcement. It's not quite true, but at least equally for enforcement. So that way, if a customer accidentally deletes their Kube dashboard, within about 5 minutes, it'll come back. So they don't have to call us up and go, hey, I accidentally deleted my Kube dashboard. Can you put it back on? Usually, by the time they realize they've deleted it, they get around to thinking about opening a ticket, it's back. Yeah.
I noticed you use a network policy. What is that one doing?
I was actually experimenting with the network policies in WatchKeeper. You can go look in the WatchKeeper. I'm a little less sophisticated in my Kube knowledge of network policies. I was kind of trying to learn something, and I put some network policies in there. All right, let's see here. So we should have all the bootstrap stuff. Bootstrap pieces on.
And, for those who don't know, network policies are like firewalls for Kubernetes, I believe. Firewalls for pods.
So you can control what a pod can do, what can reach in, what ports it can reach in, whether it can reach out. I'm still a network policy noob.
And then also freelance planning.
Okay, so on my Minikube, I forgot the full disclosure. I did create the Minikube before I got here, and if you create a Kube 116 cluster, our operators currently have problems with that. From Kube 115 to 116, they've changed the schema validation. They've made it tighter on custom resources, and our current schema definitions don't pass muster. So don't try 116 yet unless you're willing to help fix the schema. We're working on it, but it'll be a few more days. All right, so currently we have no deployments. Uh-oh. We currently have no feature flag sets either. I think we're going to have a problem here. Okay, so 6 seconds ago, I created a feature flag set on Starkly, and I'll just show you what that looks like. All right, so when I showed you on Starkly before, I'll show it to you again. We have 1, 2, 3, 4, we have 5 feature flags for this environment. And here in our feature flag set, you'll notice we have 5 attributes in the data section, 1 for each of the flags. And we can use these for other purposes. So we pull up. Close up the bootstrap, and we're going to look at remote resource bootstrap. So this is the next resource I'm going to put on. It relies on the feature flag set for its environment, and it has a number of secrets that allow it to access cloud object storage. In this case, I'm not really accessing clouds. I'm just going to raw GitHub. We're going to substitute in this configuration, And remember from the configuration, it in turn tells us what microservices this cluster should run. So when I put this on, well, that's for Mickey don't watch me type. It's about as exciting as watching the drum. So put this on, you can see it references the feature flag sector looked at. It has the URL, and it now has children. So the children are the things that it in turn has downloaded and is beginning to process. Here we have two remote resources, the config updater, which is what pulled down the configuration file. And you'll remember in that configuration file, we had another remote resource that was the bill of materials of the microservices that we wanted installed on this node. If I do this, you'll see there were two microservices that we wanted. We wanted Redis Master and front end, and that's at versions 1.0 and version 2. Now, if I go back to launch Darkly, go to Redis Master. So I'm going to change the rule to say if my cluster type is dev, I should be running 1.1. We save that. And hopefully just a few seconds later, I'll go ahead and show you the deployments we have. So we do have, in fact, front end and Redis Master running on this cluster. And again, this is all Minikube. This works with IKS. We've done it with OpenShift and AWS. I'm sure there's some Kubernetes service out there that it won't work with, but I don't know what it is yet. And we will gladly accept your pull requests to deal with that. All right. So you remember before we looked, we saw that it was pulling Redis Master 1.0, and we are now pulling Redis Master 1.1. Yay! Demo worked.
Demo work, yeah.
Always nice if demo works. That's pretty much the demo. I'm not going to demo the Kube sample app. It's pretty boring. But it's pretty interesting the first time you ever put it on and get it running. Just to know that I managed to do this thing, because there's a lot of moving parts of Kubernetes. But as you begin to move the definition, the configuration into your repos and manage it as code and use enforcement tools, which Kubernetes is all geared around enforcement, it's constantly driving at that state that you tell it you want it to be in. Even for instance, if there was a glitch with the networking, the resource request timed out, there'll be a status error in the resource. And roughly 5 minutes later, we've got a retry cycle where it'll go try to pull it again. That's my demo. That's my talk. If you have any questions, I'll try to answer them. I know some things. There's lots of other things I don't know. But thanks again for coming, for listening, and for sharing.
Can you just talk a little more about your dashboard? Because it sounds like that you're talking about information radiators that would help a lot. And I don't want to keep everybody either, but and I don't want to keep everybody picture.
So the embarrassing thing is I meant to show the dashboard and I forgot, so thank you for your question. The doubly embarrassing thing is it's apparently down. Either that or I'm going to kick off the network. I do appreciate the question. I can show you a little bit about, what the internal dashboard does. At least I think I can.
So I kind of talked to you before, we treat our pre-production environments as regions, so I'm just filtering down on this region. So this is a view of our dev cluster right now. Like I mentioned before, when we built this, we geared it really toward workloads because that's what we care most about. And as we've begun to open it up, we've shifted that perspective to arbitrary grid resources. But this is a very workload-centric view. You can see here on this particular carrier, which is the principal one developers do their testing on. You got all of the workloads. You got a reference to the containers that they're being run from. This is an integration that we did for ourselves. This is the vulnerability advisor status report. So all the ones in green passed, all the ones in high are beyond its ability to scan, and the ones in red need to do some work. This is actually a job that ran some time ago, so I suspect it was probably clean when it ran, and it's just still sitting there being scanned and is now vulnerable. The versions are the versions that we're running. This is the launch directly advertised version. So if you look here and you see a discrepancy, that means either there's some problem deploying that new resource to that cluster. We also have provision for locking a cluster down temporarily, either for debugging purposes or for test purposes. So our performance engineers, they don't like when we swap microservices out on them when they're in the middle of a performance run. So they'll typically lock them down for anywhere from a day to a week before they open them back up again. So you'll sometimes see those diverge, particularly in performance areas. And you can see the last time the resource changed, ranging from 6 days to 6 months ago. One of the things that we built here that we've got some exposure for is we can actually see the change history on these changes. So here 6 days ago, we went from commit SHA 5B206A0 to 9623B20. You can click on either of those commits and it'll take you to the GitHub tree in that spot. You click on the arrow in the middle and actually diff the two commits for you so you can see what changed. Our SRE engineers love this for that. Well, actually for both A, knowing what changed when, and B, being able to just go straight to the code and say, okay, this is what's going on.
There's also something here, Adam is a different GHE org than I am. So the Resi Dash can allow us to switch between orgs. So you can have product line or whatever.
Yeah, so one of the things we built into the open source dashboard is the ability to choose what org we're part of. Well, that's not a good one. So Cluster Store is one of the services that I personally work on, in addition to working on the Resi stuff. And here you can see all the different clusters that my code's running on, and all the different versions. I actually have a version, so if you're looking at the version, you'll see dev, pre-stage, and stage are all running one version. Got some code sitting in stage, soaking overnight before I roll it out to production. All the production clusters are running the other. One of the other things we built in to the open source as well as this version is whenever the data ingest detects a change in attributes, in version, in configuration from that it would show over on the right, it'll trigger a webhook. One of the guys on the team who was having a little fun wired it up to his Google Calendar, so every time a new microservice deployed, it put another entry in his calendar. But when you're doing like 1,000 a week, that gets completely unusable. We've done it to Slack channels. The principal use that we're making of it, of course, is to trigger those VA scans for vulnerability. We also use it to trigger an integration test suite on the cluster. So whenever something on the cluster changes, it triggers the test suite with the information of what changed, so the test suite can be selective about what test it's going to run. You got a question? Let's see if I have it there.
So basically, Resi Dash has got the numbers that the top level executives like to see.
It does. So the pie charts show what different versions of Kube people are running.
So we can begin to track. We plan to take a particular version out of service, but we still got a few too many customers running it, so we're going to hold off a little longer. Or hey, people are moving off faster than we thought. Maybe we can accelerate that. Yeah, I'm not sure why that's dead. Sorry, it wouldn't be a real demo if something didn't break. Again, any other questions? I apologize for getting to go into the dashboard. I said I write the code more than I talk about the code.
I think you go to resi-.io, sorry, resi.io, there's a demo running as well.
That's actually where I was at app.resi.io. It's down.
Oh.
I'm not sure why.
I thought you were running off your Minikube.
No, I'm not running the dashboard off Minikube. That's actually the live server. Before I left the house, there was a problem with one of the ingest APIs that Mike, Dale, and I were looking at. It was coming back up when I left, but I don't know if whatever was going on took out the app, or if they ended up having to take it out because they needed the ingest API back up because of some conflict. I can't imagine what the conflict would be, but I can never imagine what the bug is until I debug it. It's inconceivable that's broken until you understand how it's broken, of course. All right, any other questions? Well, thanks again. I'll hang around if you want to ask a more localized question. Thank you again.